Lesson 13-4, Finding Outcomes, and in this lesson, you will learn to find outcomes using lists and tree diagrams and combinations. Okay, why is this important? Because knowing how to find the number of possible outcomes can help you determine options when ordering pizza. Okay, so words that we are going to learn in this lesson are tree diagram and combinations. Okay, so Mr. Mason wrote suffixes NES and ER, LEY on the chalkboard, and then asked his students to form words using the given suffixes and the words quick, slow, and happy. How many different words can be made using the suffixes and words? To solve the problem, you can determine the sample space by making a list. So make all the possible lists: quickness, slowness, happiness, quicker, slower, happier, and quickly, slowly, and happily. So there are 9 different words that can be formed. And in this particular case, we can use a tree diagram, okay, to show the sample space. In a tree diagram, the words are quick, slow, and happy. The suffixes are ness, er, ly. So if you create your words, quickness, quicker, quickly, these are your outcomes. Slower, slowness, slower, slowly, and happiness, happier, and happily. And if you count the number of outcomes, there are 9 of them. So tree diagram becomes a very useful tool, okay, in organizing data and trying to find out the number of possible outcomes. Okay. And example number 1, at a pizza house, you can order a thin crust or a deep dish pizza with cheese, pepperoni, or sausage. Draw a tree diagram that shows all the ways you can order a 1-topping pizza. So let's look at the pizza that's available: thin crust and deep dish. Okay. And then the toppings involved, okay, are cheese, pepperoni, and sausage. Okay. And the possible outcomes would be thin crust and cheese, okay, thin crust and pepperoni, thin crust and sausage, deep dish and cheese, deep dish and pepperoni, and deep dish and sausage. So if you notice, there are 6 ways to order a 1-topping pizza. Okay? Take a look at example number 2. You have spinners. Each spinner is spun once. Find the probability of spinning blue, green, red in that order. Okay? And first, find all the possible outcomes. First, we write out spinner 1, spinner 2, spinner 3, and the number of outcomes. In spinner 1, there are 2 possible outcomes. That's your pink and that's your blue. And whenever you spin spinner 2 and you get a pink, you have another 2 possible outcomes. That's going to be tan and green. And when you get blue, you have 2 possible outcomes, also tan and green. And spinner 3, after you spin spinner 2, and after, let's say, getting pink and tan, you have 2 possible outcomes for that one as well, which is white and red. And do that with all the other spinners. So you end up with the outcome of pink, tan, and white, pink, tan, and red, pink, green, and white, pink, green, and red, blue, tan, and white, blue, tan, and red, blue, green, and white, blue, green, and red. So if you count the number of possible outcomes, there are, okay, there are 8 possible outcomes. But if you notice, okay, one outcome has blue, green, and red in that order. So there are 8 possible outcomes. So, but the possible probability of spinning a blue, green, and red is just 1 out of 8. Okay? And let's take a look at the last example. The last example, before we do that, okay, the secret word for this particular lesson would be Wichita. The secret word is Wichita. So arrangements or listings where order is not important are called combinations. In next year, we're going to talk about permutations and combinations. But just for this particular case, we're just going to discuss combinations. So combinations are another way to determine sample space. To find combinations, you can make a list. Remember, order is not important when you talk about combinations. So in a combination, let's take a look at example number 3. At Tejas Middle School, there are 5 members on the gymnastics team. Coach Reyes must choose 2 of the members to be team captains. In how many ways can he choose 2 captains from 5 team members? So she has to choose from 5 team members, and she has to choose 2 team captains. And remember, it doesn't matter what order she chooses. Okay, so in this case, order is not important in choosing the 2 team captains. So let's say we let V, W, X, and Y, and Z represent the team members, 5 of them. List all the ways 2 team captains can be chosen. So these are the possible ways: WX, WY, BW, WX, XW, YZ, WX, YW, and all the way to ZY. Okay? But remember, order is not important in combination. So when you say VW, VW is the same as VW is the same as WV here. So we simply erase one of them. WX is the same as XW. So we erase X or WX. XY is the same as YX. YZ is the same as ZY because order is not important. VX is the same as XV right there. WY is the same as YW. Where is that? YW right there. XZ, okay, is the same as ZX, and ZV is the same as VZ right there. VY is the same as YV, and WZ is the same as ZW, since order is not important. So if we do this, okay, we take out the doubles, count all of the different arrangements. Since order is not important, we take out all our doubles, okay, our duplicates, okay, and we're left with the remaining letters, okay. And therefore, in this case, there are 10 ways Coach Reyes can choose 2 team captains. Okay? And that's our lesson. Thank you for watching.